So I'm going to talk about this laser particle counter. This is usually left right here. We want to leave it with the plug, DC power plugged in, so that it will continue to charge. But when you're using it, it won't run if it's plugged in. You have to unplug it to run it, and then plug it back in and leave it here to charge. So basically what this does is it samples the air through this suction tube. It sucks in air for 1 minute, runs for 1 minute, and it sucks in a volume of air that is 0.1 cubic foot, 0.1 cubic foot. And it's measuring the scattering events with the laser, the number of scatters, and it counts the number of scatters in that 1 minute duration, which is 0.1 cubic foot. But the particle count that we normally use is the 1 cubic foot, not 0.1 cubic foot. So you take the particle count that you get, multiply by 10, that's the class of the clean room. So this is a class 100 area. We should get less than 100 particles per cubic foot, ideally, if it's low contamination. That means on the counter, it should read less than 10 after 1 minute. Depending on how you hold it, where you hold it, how close you are, all matters. So first we'll do, just by setting it on the table, turn on the power, and it'll run. You feel a motor. There's a motor that's running. You just watch. It's 0. Oh, there's 1. You picked up 1 particle. 2. If you don't move, you're stationary. It should not really produce too many particles. If you start moving, more people here, the particle count will be worse. So we'll wait to see. 3. So let it run to completion. You won't really know when it stops because it's a motor. You have to touch it to kind of feel it, or you can time it on your own. So that's actually pretty high. I wasn't expecting it to get to 4. 5. Yeah, 5 is actually getting high. So the filters are probably getting too old. So I think it's done. I can verify it. Yeah, it's done. So it measured 5 particles. The size of that is, I think, 300 nanometers size particles or larger. So you multiply by that 10. So the measured particle density is 50 particles per cubic foot. So we call it class 50. Our requirement is class 100. So that is okay. It's not. I was expecting it to be lower. That's fine. It's still good enough. But you can turn it off, and you can see if I bring it close to my gown, even though it's clean room gown, you'll see how much difference it makes. So it's running, and let me just hold it like this. See, every time I touch, whoa, look at that. It just jumped up by an enormous amount when I touch the fabric. So that tells you that the main source of contamination are people. This is 3,650. So it's way beyond what we should be. But as long as you're not moving or rubbing your fabrics, it should be a reasonable count. So instead of redoing it here, so we measured 50 here when it was undisturbed. We can measure it in the class 1000 area and see what we get. So let's set it here. This should ideally be higher. We'll see. Maybe not. It depends on the location, the airflow in that specific location. So we take particle count at multiple locations and take really an average. When you're taking the reading, step away from it. Don't be too close because then your gowns will be shedding particles and it's going to read artificially high. still low. It's actually pretty close to what we read in class 100. So this area is class 1000, so if we stay below 100 on the count, it's still good. So I think it's going to be just fine. Okay, it's 5. I don't know, is it done? We can use the stopwatch and then, yeah, it's done. So this is 50, just the same as in the class 100. That's kind of interesting why it is the same. It really should be worse here. If I go close to the door, it's going to read worse because the cleaner areas are farther from the door. So let's try it. Let me put it here. Yeah, it's definitely going to be higher. 4, 5, 6, 7, 8. So you can see it is worse in this spot because it's close to the door. Now if you go outside of the door, you'll see the dramatic difference what happens outside. So it's still going to be okay for class 1000. See, it's only 11 particles multiplied by 10 is 110, so it's not too bad. 14. I wish it had a little clock that tells you when it's done. Yeah. So 15. So 15 times 10, 150 particles per cubic foot. So still well below 1,000 threshold. Now let's go outside into the gouting area and we'll retake the reading and we'll see the difference. So let's turn it on and see the numbers will go up really fast. So that I don't influence the reading, I'll put it here. There. See the count. It's going to max out. It's I think it gets to 99999 or something. It'll max out. Yeah, so you get the idea. So this is going to max out. It's not going to be useful reading. Now, it could also be coming from the chair itself. It's made of some fibrous material, or it's the room itself is not as clean. It's actually still a clean room. This is part of the clean room, and this is I think it's 10,000, class 10,000. This is showing above that, right? It's 1,200 times 10 is 12,000. So it's actually not 10,000, even though it was meant to be 10,000. That's because we have, look at all the cardboards, all kinds of furniture with fibers and fibrous material. Those are all the wrong material for a clean room. So as a result, this is not really good number. So that's the reason we place equipment in places that we do. Lithography is the most critical, so we put it in the farthest area of the class 100. The other things that are less critical, we put them close to the door. So I think that's good.